Ammonia. Ammonia, the chemical formula of ammonia is NH3. It is basic in nature, pungent choking smell. It has a pungent smell and colorless gas. It is a base, so it is always, we know base are bitter in taste as it is alkaline. Ammonia is alkaline. Alkaline means what? The bases which is dissolved in water called alkaline. So ammonia is a base, so that's why it is bitter in taste, and we know acids are sour in taste. Now what is the structure of ammonia? Ammonia, we know in nitrogen, we know it has 5 electron in the last orbit, right? Nitrogen is in 7, so atomic number is 7. So in the first orbit it has 2 electron, and the next orbit it has 5 electron. 1 2 3 4 5, and always we draw the last orbit electron, so it has 1 2 3 4 5, and these two are known as lone pair electron. We have learned in chemical bonding. And the three hydrogen will be there, and hydrogen in the last orbit they have 1 electron, right? So with 1 electron they will make a bond, right? In this way they nitrogen bond with 3 hydrogen, so it has a lone pair electron. So now you can ask me, ma'am, why ammonia is basic in nature? We know base, they must contain a O or OH, oxide or hydroxide, but in ammonia there is no oxide, no hydroxide. So why ammonia is basic in nature? Why ammonia is basic in nature? Because you see, all the bases must contain O or OH group according to Arrhenius. But Lewis, one scientist, he told that if they have lone pair, then they will act as a base. So lone pair means basic in nature. Who told this? Lewis. So why ammonia is basic? It has a lone pair electron according to Lewis, not according to Arrhenius. Okay. Now the lab preparation of ammonium. In lab preparation, ammonia salt, we have to take a ammonium salt. Alkali means the bases which are dissolved in water, and it will produce ammonia gas, salt and water. So we see one example, ammonium salt, NH4Cl we have taken, plus alkali means NaOH, it has OH group, that's why it is a base, and it will give NH3, water and NaCl. The salt is NaCl. Now another ammonium salt we can take, NH4 whole 2 SO4, ammonium sulfate, plus ammonium is always, you remember, NH4. Ammonia is NH3, but ammonium NH4. Alkali KOH, it will produce we know ammonia gas, salt and water. Ammonia, water, and this is the salt. But in lab we always take CaOH whole 2. Okay, in lab preparation of ammonia we take, this is select lime, we can say select lime. Okay, so NH4Cl is the ammonium salt. With this we will take the select lime, that is CaOH whole 2, and it will give ammonia, water and salt. Okay, so why we don't use KOH and NaOH? Because NaOH and KOH are deliquescent, means when it comes in contact with atmosphere it absorbs moisture and dissolve in it. That's why we can't take NaOH and KOH. We always have to take CaOH whole 2. Now the ratio of NH4Cl and COH whole 2 is 2:3. Acha, NH4Cl is sublime, means it shows sublimation. So that's why we will take 2 ratio of NH4Cl and 3 ratio of CaOH whole 2. Now you can ask me, ma'am, NH4Ca it shows sublimation, so we have to take more amount of NH4Cl, right? But no, it is more high cost, and it has a lower cheap cost. That's why we take this in more amount and this in less amount. Clear? Now how we do this process in lab? You see there is a tilted flux is there. We are providing heat here, and we have taken in this jar, that is CaOH whole 2 and NH4Cl in the ratio 3:2, right? CaOH whole 2 3 and NH4Cl 2. It will produce ammonia and water. So here ammonia and water is producing. They are coming here, and here is a pipe which is connected with another jar, okay, and here is another pipe, here is another jar. So from here the NH3 on water will come here, okay, NH3 and water, and here we have taken some drying agent, that is CaO, quick lime, okay. CaO will absorb all the moisture here, means all the moisture means here H2O, it will absorb and only ammonium gas will be there. So this ammonium gas will come here and we will collect in this jar. So in this way we collect ammonia. So now one question come, ammonia is collected by downward displacement of air. Why? Ammonia is collected by downward displacement of air. Why? Because ammonia is lighter than air, okay, and ammonia is lighter than air, that's why it will come upside, right? And ammonia is highly soluble in water. This is the two reason for that we collect ammonia as a downward displacement of water. Now why we have taken this tilted flux? Answer: water vapor it does not trickle back and break the glass. Okay, so what happen if we take we have taken a tilted glass? That's why, because here CaOH and NH4Cl will react, they will produce ammonia and water. This water will come upside and it can break the glass of this jar. Not we have taken a tilted flux. Why? Because this water vapor will come here, okay. Otherwise if this is not tilted, it is straight, then all the water vapor will come upside and it can't escape. That's why it may break the glass. That's why we have taken a tilted flux. Why concentrated H2SO4, P2O5 etc. cannot be used to dry ammonia? Why we have taken CaO, calcium oxide, or quick lime? Why we have taken? Why we have not taken H2SO4, P2SO4 or other acids? CaO and NH3 both are basic because it has O group, and NH3 also is a basic because it has a lone pair. So both are basic, they will not react between them, okay. But if we take H2SO4, P2O5, these are acids. So acid when react with base means ammonia is a base, they will produce salt and water, another salt will produce there, right? Another reaction will take place. That's why we will not take any acids here as a drying agent. We cannot use NH4NO3 for this process, okay. We are using NH4Cl. Why we are not using NH4NO3? Because NH4NO3 is highly explosive. So you see, if we heat it, it will give N2O and H2. So decompose on heating and it will break into N2O and H2, and it is very explosive. That's why we will not take NH4NO3. And always you remember, we will take CaOH whole 2 as it is very cheap, okay. That's why we will take this. Now we can also get ammonia from metal nitrates, okay. So when metal nitrates react with hot water, it produces ammonia and metal hydroxide. So reaction we will see first. Mg3N2, magnesium nitrite. Nitrite means here Mg, the valence is 2 plus, N 3 minus. That's why 3 will come here, 2 will come here, right? And if it react with hot water, it will give ammonia, magnesium hydroxide, metal hydroxide, right? Again we can take another metal nitrate, that is aluminum nitrate, Al3 plus, N also 3 minus, so 3 cut, that's why Aln. When it reacts with hot water, it also gives ammonia and metal hydroxide. But you remember that these metal nitrates are very costly. That's why we don't use this process to get ammonia. Okay, so here this is the very easy process, and here calcium hydroxide is very cheap, that's why we do this process to get ammonia in lab. But these are the metal oxides are very costly. Okay, so these processes are very costly. Now preparation of aqueous ammonia. How we will prepare aqueous ammonia? Aqueous ammonia means water will be there, ammonia will be there. Ammonia is highly soluble in water. You remember always that ammonia is highly soluble in water. So the rate of dissolving ammonia is very fast, and the rate of production is slower. Here ammonia is producing slower. Suppose here ammonia gas is producing. Here we have fit a pipe, and here is water. So when the ammonia gas will come, it will fast dissolve in the water. The production is slow, but the dissolving ammonia when dissolve in water, that is very fast compared to the production of ammonia. Okay, so here ammonia, suppose here ammonia gas is producing, ammonia gas will come here through this pipe, and the dissolving manner is very fast. Okay, the ammonia will dissolve in this water it very fast because it is highly soluble in water. Now what happen if we do this process, then what happen? You see, ammonia is coming through this pipe, and it is highly dissolving in water. Okay, now there is a problem in this process. What happen? You see here ammonia is producing is very slow, and a slower rate. According to ammonia, the dissolving manner of ammonia is very fast because ammonia is highly soluble in this water. So all the ammonia will come here, and they will attract all the ammonia in this water. So here will be a space will create, and that is the vacuum will create here. Okay, now what happen? You see atmospheric pressure will act on this water. So when atmospheric pressure act on this water, so here will be a back pressure, and these water with this ammonia will go now in this pipe. So this is called the back suction process. To prevent this back suction process, we use a inverted funnel arrangement. So what happened? All that due to this atmospheric pressure, now these water, ammonia is coming here, ammonia is dissolving in this water. Now atmospheric pressure, and all the ammonia comes here ammonia is producing, but it is coming very slow. So that's why when all the ammonia will come here, at that time there will be a vacuum will create here, a free space will create here, that means the vacuum. And here all that here atmospheric pressure is acting, and due to it will go backside. The water along with this ammonia, aqueous ammonia, will go backside, and this is called back suction process. To prevent this process, we use a inverted funnel arrangement. You see, we use a inverted funnel arrangement, and the funnel gives a larger surface area, right? So the rate of dissolving ammonia is less. Why? You see here ammonia gas is producing, it is coming, the surface area is more, so here the ammonia will spread all the sides, and the dissolving, it will dissolve very slowly. Here it is dissolving so fast because ये जो पाइप है इसमें इससे एमोनिया को वो डायरेक्टली खींच लेगा, बट ये देखो ये सरफेस एरिया बहुत ज़्यादा है, तो ये पहले ये एमोनिया पूरा पाइप के अंदर स्प्रेड हो जाएगा, उसके बाद डिज़ोल्व होगा. सो इट इज़ टेकिंग टाइम. सो एट when it is taking time, at that time more ammonia will come here, right now. And here the time, it is very fast process because ammonia is through this pipe, ammonia is directly coming in this water. Here the funnel is there, that's why. And another thing, when the atmospheric pressure will create here, at that time what happen, this funnel will go upside. Okay, this funnel will go upside, that's why the back suction process will not take place. Okay, so this is the way, that's why we take this funnel arrangement. Clear? Acha, now the properties of ammonia. We have already learned some properties of ammonia before, that ammonia is highly soluble in water, ammonia is basic in nature, it has a pungent smell, all we have learned. Now we know that's the main important property, that ammonia is highly soluble in water. So that's why we do a fountain experiment to prove this. Now in this fountain experiment, what we will take, we have taken a beaker. Here we have taken red litmus solution. Here is a inverted vessels. We have kept inverted vessels here. Here will be a dropper, here will be a funnel. Okay, in this dropper water is there. Okay, and in this inverted vessel full ammonia gas is present. Ammonia gas in a full this inverted vessel is totally with full ammonia gas. Okay, and this is the jet tube. Okay, and here is the dropper. So what we will do, first the dropper is squeezed, so we will squeeze the dropper and the water here will come in this inverted vessel. So water will rush into the vessel. Ammonia is present in the vessel, so ammonia, we know ammonia is highly dissolved with water, so ammonia will dissolve in this water, form dropper. So what is how in if which rate ammonia dissolve in water? In 1 centimeter cube of water, 2702 centimeter cube of ammonia solution can dissolve. There will be a slight vacuum in vessel, because if all the ammonia dissolve in this water, so there will be a vacuum, a vacuum will create. Okay, so now due to the atmospheric pressure, again due to this atmospheric pressure, this solution, this red litmus solution will come will go in back. There will be a back suction pool. So here in the jet tube the red litmus solution will go, and when it comes here, we know here ammonia is there, so ammonia, it's a basic solution. We know base turn red litmus blue, so here we will see a blue fountain. So ammonia turns when due to this atmospheric pressure the red litmus reaches upwards through the jet tube, reaches the vessels, and ammonia turns the red litmus blue, and we observe a blue fountain. So this is the fountain experiment. Okay, this is very important. You have to draw and you have to write the experiment. This is very important. Now the properties of ammonia, already we have learned. It is basic in nature due to the lone pair. So aqueous ammonia, NH3 plus water, when they react it gives NH4OH. Okay, NH4OH is a weak alkali, so it will break NH4 plus OH minus. Next, reaction due to basic nature. We know acid and base produce salt and water, but ammonia is due to this, it is Arrhenius principle. In Arrhenius principle we know that the bases must contain O and OH group, and the acid must contain a H plus ion, right? And here in ammonia there is no H, no O, no OH minus ion, no OH minus, no O minus ion. Here in ammonia the lone pair electrons are present, and according to Lewis. So according to Lewis, acid when base react, they produce salt but no water. So here HCl is a gas, it is also acidic gas. When it react with ammonia with gas, it form NH4Cl but no water. It's a dense white fuse NH4Cl form it in the solid state. So gas it's making solid. Now in H2SO4 when react with ammonia, it is also acid, it will form NH4 SO4 means ammonium sulfate. Aqueous ammonia when react with acid, it produce salt and water. Aqueous ammonia means we know NH4OH. Here I told you na, aqueous ammonia means NH3 plus water, it form NH4OH. So aqueous ammonia we can take NH4OH. When react with acid we have taken HCl, it will form NH4Cl plus water, salt and water. Here also NH4OH plus H2SO4, it will produce NH4 and water. So these are the salt and water is producing when aqueous ammonia react with acid. But when normal ammonia react with acid, it will not produce water, it will only produce the salt. Now ammonia is a very good reducing agent. It's a reducing agent means what? Reducing means oxygen will hydrogen will add, oxygen will take out, right? This is called the reducing property. So here CuO when react with ammonia, this is black color, you see oxygen is leaving from here, right? So this is the reduction. Oxygen is gaining of oxygen is oxidation, but removing of oxygen is reduction. So oxygen is getting out here from here, and it is producing copper, water and nitrogen gas. Here the red ppt of copper will form from black. Okay, this is CuO, copper oxide. Reaction with chlorine. Chlorine again when react with ammonia, excess amount of ammonia, it form nitrogen gas and NH4Cl. The dense white NH4Cl gas will produce, and chlorine is greenish yellow in color, but the color will get changed. Greenish yellow color disappears when this reaction, after this reaction. Okay, here we are taking ammonia in excess amount. Now if we take chlorine in excess amount, if it react with ammonia, it form hydrochloric acid and NCl3, and it is in yellow liquid. So the difference you have to remember, here we are taking ammonia in excess amount, here we are taking chlorine as in excess amount. Now combustion of ammonia. Ammonia does not burn in air. Okay, ammonia does not burn in air. Okay, but it burns in oxygen, in presence of oxygen. So when ammonia react with oxygen, it produce nitrogen gas and water. We have balanced the equation, and we will see yellow green flame of ammonia gas when it burn in presence of oxygen. Reaction of oxygen in presence of a catalyst. Ammonia react with oxygen also in the presence of a catalyst, that is platinum, and the temperature we have to take 800 degrees centigrade. Now in this reaction we will see ammonia when react with oxygen, it producing nitrogen oxide gas and water. Nitrogen oxide gas, again here excess amount of oxygen will be there in this process. So again nitrogen oxide react with excess oxygen, and it will form nitrogen dioxide. And here is two observation we see in this reaction, that is one, reddish brown gas of nitrogen dioxide we will see, and platinum continues to glow even after heating is stopped. Okay, so after heating is stopped, platinum also glow as red. So these two observation we will see. Okay.